Hello again, this is Physics Review video number 9. This is on work and energy. Energy comes in 3 flavors, 3 forms. Neapolitan ice cream comes in 3 flavors. They are chocolate, vanilla, and strawberry. Work, or energy, comes in 3 forms. Energy comes in potential, kinetic, and work. They're all measured in joules, right? All measured in joules. So, when you think of energy as like in Transformers, you know, like you ever play with Transformers as a kid? They can transform from a car to a robot, and it's pretty tricky. Mechanics at the bottom is where we are for work and energy. So from potential energy equals mgh down, it's all talking about energy. So energy is the ability, hope that's on the, hope it's not getting cut off, to do work. And like I said, work and PE and KE are the 3 forms of energy. They're all measured in joules, you remember, okay? And then, so if you write down, making a list of knowns and unknowns, then you may find that you're given mass and speed or velocity, and they ask about the potential energy, like you throw a ball up in the air or throw a baby up in the air with a mass of 2 kilograms, little baby. Nah, let's make it 12 kilograms, fat baby. So 2 kilograms, and you throw it up with a velocity of, say, 10 meters per second, and you want to know how high that baby's going to go. Well, the answer, right off the top of your head, you should know is 5 meters. But you could figure that out by setting potential energy equal to 1/2 mv squared. The reason the answer is 5 meters is because if you toss it up with 10 meters per second, gravity grabs away about 10 every second that something rises. Excuse me, so it's going to take 1 second for it to go up, and what goes up must come down. So it's going to take 1 second to fall. That makes it 1 second falling 5 meters. But you could do the same thing right here. You could do 1/2. You got your 12 kilogram fatty little baby, and you've got your velocity, I said was 10. So that's going to be equal to potential energy, and so we could also set that equal to mgh. So that's going to be equal to mass times gravity times height. And so now you're going to have 12 kilograms over here, 10 meters per second squared. Plugging these numbers in for that. And your height is what you're looking for. It's going to equal 1/2 12 times 10 meters per second squared. So 120 times, switch markers here, 120 times h equals 1/2 of 12 is 6, 600. 600 divided by 120 is going to give me an h of 5 meters. So that's what we figured out before. So those kind of things you can do with energy. So notice how potential energy and kinetic energy equal the same thing. And the question might be, you know, how much energy was there? Well, if you look over here, what we did, 1/2 times 12 is 6 times 100, so it's 600 joules of energy. And you'll get 600 joules of energy on that side too, because they're equal. The only thing that will take away energy is friction, either air friction or sliding friction. So, there's another equation for this topic. Work equals force times distance. Okay, we need to know that one. We talked about PE equals mgh. You got to know that one. Kinetic energy